Lesson 2.7, we're going to prove angle pair relationships. So we're going to be dealing with proofs and some topics that we've actually discussed in class where now we're going to put some theorems to them. So first of all, we're going to have the right angle congruence theorem. So it would make sense that the right angle congruence theorem tells us that all right angles are congruent. When we have theorems, the reason we want to have theorems is because they cut down what we need to do in a proof. So we can then use theorems, things that we've proven, in future proofs. Now, in order to give us a little practice with proofs, we are actually going to walk through the proofs of these theorems. So here is, we're going to actually prove that the right angle congruence theorem, which says that all right angles are congruent, works. Makes sense because we know that all right angles are equal to 90 degrees. 90 degrees is 90 degrees is 90 degrees. So we are given that angle 1 and 2 are right angles. And so we can measure and see that the measure of angle 1 is equal to 90 degrees and the measure of angle 2 is equal to 90 degrees. So number 1 was given. Number 2 is we know that a right angle is 90 degrees. If somebody asks you what is a right angle, it's an angle that measures 90 degrees. So step number 2 is we're actually defining this word in statement number 1, definition of a right angle. Now, if the measure of angle 1 is 90 degrees and the measure of angle 2 is 90 degrees, so they're both 90 degrees, their measures are going to be equal to each other. That is the transitive property of equality. And step number 4, if angle measures are equal, then they are congruent. That is the definition of congruent. That's the congruent symbol. So that is a proof for the right angle congruence theorem. That way, when we actually have to use angle congruence, it cuts down on our steps. And I'll explain that here with this proof. So this proof shows that segment AB is perpendicular to BC and DC is perpendicular to BC. Okay, so our reason is given. Now, since we're using the word perpendicular here, although we're using a symbol, it stands for the word perpendicular, we want to think about what does perpendicular mean. And perpendicular means that when the lines intersect, they form right angles. So angle B and angle C are right angles. That is the definition of perpendicular. This is what perpendicular means. And we just learned that all right angles are congruent to each other. So if they're right angles, they're congruent to each other through the right angle congruence theorem. Now, if I didn't remember the right angle congruence theorem, I could have said that angle B and C are right angles, definition of perpendicular. Then I could have said angle B and angle C are equal to 90 degrees because that would be the definition of a right angle. Then I could say, since angle B is equal to 90 degrees and angle C is equal to 90 degrees, that the measure of angle B and the measure of angle C are equal to each other from the transitive property of equality. Then, from there, I could have then said, since the measure of angle B is equal to the measure of angle C, that angle B is congruent to angle C through the definition of congruence. So I would have had these first 2 steps, and then I would have had definition of a right angle, transitive property of equality, definition of congruence. So instead of these 3 steps, I'm able to use right angle congruence theorem, and I save myself steps. We also learned about, in class today, congruent supplements theorem and congruent complements theorem. And we talked about these one day in class. I'm going to write over here. where I had angle R, angle S, and angle T. And in the problem I had in the warm-up, I said angle R, let's do supplement first, is a supplement of angle T. So let's say angle T is 40 degrees. If R is a supplement to T, it's 140 degrees. Now let's also say, and I tell you that R is a supplement to T, and S is a supplement to T. So it's 140 degrees also. That means that my two angles, R and S, are going to be congruent. So if two angles, R and S, are supplementary to the same angle, okay, they're supplementary to T, then they are congruent to each other. That also works for the congruent complements theorem. So I'm going to use this same example, but I'm now going to say that R and S are complements to T. So if T is 40, R is 50, because it's a complement to 40, and S is 50. It's a complement. Complement meaning they add up to 90 degrees. So now, if they are complements, these two angles are complements to the same third angle, then they are congruent to each other. Okay? So we're going to walk through a proof of this. So obviously, if you want to, at any time during the video, you can stop, freeze it, see if you could fill in these reasons as extra proof practice. So in this proof, angle 1 and 2 are supplements, and angle 3 and 2 are supplements. That's what we're given. So since we have that word supplement, probably a good idea to talk about what that means. Well, that means that if I add their measures together, it equals 180 degrees. That is a definition of supplements. Okay? Now, if this is equal to 180 degrees and this is equal to 180 degrees, since they're both equal to 180 degrees, they're equal to each other. That is the transitive property of equality. Now, to get from here to here, you notice we have a measure of angle 2 on both sides. We're taking it away. We are subtracting. So that's the subtraction property of equality. And then, because they are equal to each other, they are also congruent. That's the definition of congruent. So we walked through these steps to prove a case of the congruent supplements theorem. Okay? So just real quick, how many steps did we save in the proof of example 1 by using right angle congruence? We saved 3 steps. Okay? Draw a diagram and write given and prove the statements for a proof of each case of the congruent complements theorem. I'm not going to do that, but basically this would be the same thing here, but instead of supplements, we'd be writing the word complements. And instead of 180, we'd be doing 90. And the answer would be definition of the word complement. That's how we would do that. We also had today some theorems about linear pair postulate and vertical angles congruence theorem. We have learned about both of these already in class. We're just putting the words postulate or theorem with them. So a postulate is something that we do not need to prove. We generally accept it as true. And if you remember in class, we have spent time talking about what a linear pair is. And we've talked about the fact that a linear pair, they are on the same straight line, so they are supplementary, and so the sum of the measure of their angles is 180 degrees. Rather than having to repeat that every time now, we can use linear pair postulate and we can save ourselves a lot of words. Vertical angles congruence theorem. Vertical angles are congruent. We talked in chapter 1 about if two lines intersect, they form two pairs of vertical angles, and vertical angles are congruent to each other. Now we actually have a theorem. So now we have an example of how we would actually use this to solve a problem. So which equation can be used to find x? Well, we see that TPQ measures 32 degrees and QPR measures 3x plus 1. So if we add them together, they should equal 180 degrees because they are a linear pair. So the correct equation would be equation B. Okay, now solve for x. So we said that the equation would be 32 plus 3x plus 1 equals 180. That means that 33 plus 3x equals 180. We would subtract by 33 on both sides, and we would get 147. And 147 divided by 3 is 49. So x is equal to 49 degrees. Now if they wanted us to find, so x was 49, sorry. They wanted us to find TPS. Well, TPS is vertical to QPR. So whatever QPR is, TPS is going to be congruent to it. So 49 times 3 is 147, plus 1 is 148. So TPS is 148 degrees. That's it for what we're doing in the lesson. These are the pages which your homework is from. Thank you for watching.